Say you were peeping on your neighbor's wife. You were so fascinated of what you're currently seeing without knowing that a kid is sneaking behind you. Being the brat that he is, he threw a water balloon at you without even hesitating. As he continued mocking you, you were already on the backyard, filling up a balloon with water. Come on, make it bigger. Bigger, more water the better. You were so pissed off that a water balloon could kill a child. And it did. Believe it or not, you demonstrated Avogadro's law. A law stating that equal volumes of gases at the same temperature and pressure contain equal numbers of molecules. More water, the bigger. More particles, more volume. Here are some examples. As you blow up a basketball, you are forcing more gas molecules into it. The more molecules, the greater the volume. The basketball inflates. Another example are car tires. A flat tire takes up less space than an inflated tire, because an inflated tire has more molecules in it.
A 6-liter sample at 25 degrees Celsius and 2 atmosphere of pressure contains 0.5 mole of a gas. If an additional 0.25 mole of a gas at the same temperature and pressure are added, what is the final total volume of the gas?
So for the first sample problem, we are given an initial volume, initial mole, and final mole. We are tasked to find the final volume. So since it's Avogadro's law, we will use this formula. Initial volume over initial mole is equals to final volume over final mole. So since we are finding for initial volume, we will divide both sides by initial mole and substitute the following given to the formula. And 6.0 liters times 0.75 mole divided by 0.50 mole. So cancel the mole, we will have 9. And since we have two significant, since that significant figures we have is 2, we will have two significant figures for the final answer. And that is 9.0 liters.
3 balloons are filled with different amounts of an ideal gas. One balloon is filled with 3 moles of the ideal gas, filling the balloon to 30 liters. A. One balloon contains 2 moles of gas. What is the volume of the balloon? B. One balloon encloses a volume of 45 liters. How many moles of gas are in the balloon?
So for number 3, there is a basis. Number of moles is equal to 3. Volume is 30 liters. And divided into 2 parts. For the part A, the given is 2 moles and the volume is asked. And for the part B, the volume is given, which is 45 liters, and the number of moles is asked. So for the formula, we are going to use the Avogadro's law. V sub 1 over N sub 1 is equal to V sub 2 over N sub 2. So for the solution for the part A, so 30 over 3 is equal to X, which is the volume we are looking for, over 2. Cross multiplication, 60 is equal to 3x, and by simplification, volume is equals to 20 liters. And for the part B, wherein the number of moles are asked, 30 over 3, just like what we did at the part A, is equal to 45 liters over x. Simplification and cross multiplication, 10x equals 45, which is the number of moles is 4.5.
A balloon has been filled to a volume of 1.90 liter with 0.920 moles of helium gas. If 0.0210 moles of additional helium is added to the balloon while the temperature and pressure are held constant, what is the new volume of the balloon?
Here's the solution in number 2. The given are V sub 1 equals to 1.9 liters, N sub 1 equals 0.0920 moles, and N sub 2, which is 0.1331. We get this by adding N sub 1 to 0.0210 moles. In Avogadro's number, here's the formula. V sub 1 over N sub 1 equals to V sub 2 over N sub 2. So by cross multiplying, we are finding V2. So by cross multiplying, we can get this. By substituting 1.9 liters times 0.1331 moles and 0.0920 moles, we cancel the same units, then we get 2.3695 liters. And since the significant figures are only 2, so we get 2.3 liters.
Like a bird on a tree, I'm just sitting here. I got time, it's clear to see from up here.